Launched in 1977 by NASA, the Voyager 1 spacecraft holds the extraordinary title of being the most distant human-made object ever created. Now traveling through the interstellar medium, far beyond the boundaries of our solar system, Voyager 1's journey has exceeded every expectation and milestone once thought possible. Originally, this mission was intended to last only 4 years. But today, more than 45 years later, the spacecraft remains operational, continuing its silent odyssey into the unknown. Equipped with what is now considered ancient technology, comparable to cassette players of the same era, Voyager 1 continues to astonish both scientists and the public by sending back data from incomprehensible distances. The spacecraft's endurance and performance have allowed it to explore regions of space never anticipated during its initial planning, transforming it into one of the most iconic scientific instruments in history. The origins of this groundbreaking mission can be traced back to a visionary NASA scientist at the Jet Propulsion Laboratory, Gary Flandreau. In the 1960s, Flandreau discovered a rare planetary alignment that would occur in the late 1970s and early 1980s, an alignment that happens only once every 176 years. This celestial arrangement would allow a single spacecraft to visit Jupiter, Saturn, Uranus, and Neptune in one continuous journey by using the gravitational pull of each planet to slingshot itself to the next. This technique, known as gravity assist, enabled the craft to accelerate and alter its trajectory with minimal fuel consumption. Seizing the opportunity, NASA moved quickly. Within just 15 days, 2 identical spacecraft, Voyager 1 and Voyager 2, were approved, built, and launched in the summer of 1977. This rapid action marked the beginning of a mission that would go on to shatter records and redefine humanity's understanding of the outer solar system. Voyager 1's journey began with a daring passage through the asteroid belt, followed by close encounters with Jupiter and Saturn. These gravity assists were not just navigational feats. They also provided Earth's first close-up images of these gas giants and their moons. Initially, the mission was only meant to last until the spacecraft completed a flyby of Saturn. But both Voyager probes performed so remarkably well that NASA decided to extend the mission indefinitely. The data returned from Voyager 1 and its twin revolutionized space science. Among their many discoveries were active volcanoes on Jupiter's moon Io, complex weather systems on Saturn, and astonishingly detailed images of the planet's rings. These findings reshaped our understanding of planetary formation and dynamics. Voyager 2, on its parallel path, became the first and only spacecraft to fly past Uranus in 1986, revealing a cold, distant world shrouded in mystery. 3 years later, it completed its grand tour by visiting Neptune in 1989, sending back stunning images and valuable scientific data. By this time, both spacecraft were so distant that their signals took hours to reach Earth. Yet, they continued transmitting, overcoming vast distances and technical limitations. Eventually, Voyager 1 reached the outer edge of our solar system, the heliopause. This boundary marks the point where the sun's solar wind is no longer strong enough to push against the interstellar medium. In 2012, Voyager 1 crossed this threshold and officially entered interstellar space, becoming the first human-made object to do so. This was not just a milestone in engineering, but a moment of profound significance for humanity. Scientists had predicted that this transition would be marked by a dramatic increase in cosmic rays, high-energy particles traveling through space, and a noticeable shift in the magnetic field. Surprisingly, while Voyager did detect a rise in cosmic ray density, there was no major change in the magnetic field. This puzzled researchers and challenged long-held theories about the structure of the heliosphere and its boundaries. The spacecraft's instruments provided unexpected and groundbreaking data about the nature of interstellar space. For instance, Voyager 1 detected that the interstellar magnetic field was more aligned with the heliosphere than previously thought. This forced scientists to rethink how magnetic forces operate beyond the solar system. The probe also measured plasma density in the interstellar medium, suggesting that the space between stars might be more structured and complex than we imagined. As Voyager 1 and 2 continue to drift into uncharted territory, they carry with them a message from Earth, the golden records. Encased in protective aluminum and engraved with playback instructions, these phonograph records contain greetings in dozens of languages, sounds of nature, music from different cultures, and images portraying life on Earth. Meant as a cosmic hello to any intelligent beings that might find them, the golden records symbolize humanity's desire to connect, explore, and leave a mark, even in the vast emptiness of space. What's perhaps most astonishing is that the Voyager spacecrafts were built with extremely limited onboard memory, only about 69 kilobytes. By comparison, even the simplest smartphone today holds billions of times more data. And yet, these relics of the 1970s have traveled farther than any other machine in history, continuing to function despite dwindling power and aging components. Maintaining communication with the Voyager probes has become increasingly difficult over time. The signals they send are incredibly faint, having to travel billions of kilometers through space and past the interference of Earth's own radio noise. Still, NASA's Deep Space Network, an international array of large radio antennas, uses advanced filtering techniques to lock onto these weak signals and retrieve data that would otherwise be lost in the static. As the spacecraft continue their voyage, their nuclear power sources, the radioisotope thermoelectric generators, are gradually losing energy. Within the next decade, the probes are expected to cease operations entirely. But even after they fall silent, their legacy will live on. The scientific insights gained from the Voyager mission have fundamentally changed how we view the solar system, its formation, and its place in the galaxy. Voyager has expanded the frontiers of human knowledge and demonstrated what's possible when ambition meets innovation. These spacecraft are more than just machines. They are monuments to human curiosity and ingenuity. Over 14 billion kilometers from Earth, the Voyager probes remain our furthest emissaries, carrying our messages, hopes, and knowledge across the cosmos. They remind us that even with old technology, we can reach extraordinary new horizons. They teach us to keep questioning, keep exploring, and never stop wondering about what lies beyond. In the end, the story of Voyager is not just about spacecraft. It's about people, scientists, engineers, and dreamers, who dared to look up at the stars and imagine something greater. The Voyager mission has inspired generations, sparked imaginations, and deepened our understanding of the universe. And though these explorers will one day go silent, their journey will continue, for thousands, perhaps millions of years, as they drift endlessly through interstellar space, carrying with them the essence of who we are and the spirit of where we've come from.